That's an excellent summary of the absolute necessity of railroad preemption in interconnected downtown traffic systems. You're highlighting the difference between a normal, timed signal and the immediate, critical safety interruption caused by a train. Here's a breakdown of how downtown signals, which may be pre-timed or lack typical sensors, handle preemption, and the difference between the two main types you mentioned. 1. Downtown signals and sensors. You are correct that many downtown areas use pre-timed, fixed-cycle, traffic signals. Pre-timed control. These signals operate on set, repeatable time intervals, which is useful in dense urban grids where traffic volumes are heavy and consistent, but they often lack the vehicle sensors, like in ground loops or cameras, used in other areas. Preemption overrides all. When a railroad preemption call is received, the traffic signal controller must immediately interrupt its normal operation, whether it's pre-timed or actuated, and replace it with the specialized preemption timing and logic. 2. The core safety sequence, immediate end of cycle. Regardless of the type of preemption, the initial safety goal is the same: clear the tracks and stop traffic from approaching them. When the preemption call is received, the signal must terminate the current phase immediately. The sequence is mandatory: right-of-way transfer. This phase quickly terminates any existing vehicular or pedestrian movements. The controller must meet a minimum green, walk, and pedestrian clearance time before forcing the phase to end. Track clearance phase. This is the most critical step. The signal provides a green light, or appropriate arrow, long enough to ensure any vehicles that might be stopped on or immediately approaching the tracks are given enough time to clear the entire track area. Dwell, limited cycle. All movements that cross the tracks are turned red, and the signal runs a limited cycle or simply dwells on phases that do not conflict with the train, like the parallel movement or a safe turn. 3. Advanced versus simultaneous, synchronized, preemption. The difference between the two types you mentioned lies in when the traffic signal is notified relative to when the train warning lights start flashing for the public. Type of preemption. Timing of notification. Purpose and impact. Simultaneous or synchronized traffic signal is preempted at the same time the crossing flashers begin to activate. Requires a longer track clearance phase because the traffic signal has less lead time to clear traffic queues before the gates start coming down. Advanced traffic signal is preempted prior to the crossing flashers beginning to activate. Provides more time for the signal to run phases that will clear traffic queues, which is critical in downtown areas where traffic can back up over the tracks, the preempt trap. Advanced preemption is essential in congested urban areas because it gives the traffic signals the necessary lead time to clear the entire queue off the track, well before the train arrives and the gates start to descend.